iGenius Intelligent Gripper, using edge neural AI and imitation learning in user-assistive industrial settings. Co-funded by the European Union under the Arise Open Call framework, iGenius is led by MYWAI in consortium with GRF and the University of GENOA. In large-scale manufacturing, workers perform repetitive pick-and-place tasks every day. Programming robots for each task is costly and time-consuming. The project addresses the core challenge in industrial automation in order to enable the robots to learn new tasks from a single human demonstration. iGenius enables one-shot imitation learning for industrial pick-and-place. From a single video captured by Z camera, the system extracts a complete robotic skill. The process begins with a single demonstration. A human operator performs the pick-and-place task once. The Z camera captures both video and depth. One camera, one take, that's all the system needs. iGenius architecture is based on two sets of toolkits. First is VILMA Visual Imitation Learning Mimicking Agent. The MYWAI technology manages the AI pipeline data storage and task organization. Alternatively, users can work directly with the local file system for data management, keeping the workflow flexible. The iGenius toolkit runs the AI pipeline, a lightweight chain from hand detection through object detection, trajectory extraction, DMP, which is dynamic movement primitives encoding, to grasp and release detection. Importantly, the only deep learning component iGenius toolkit for detection, the trajectory extraction and DMP encoding, are analytical, not learned from large datasets. VulcanXus, a ROS2 distribution, handles real-time robot communication and edge deployment through the node. Once the trajectory is generated, it is sent to the edge system at the University of GENOA, where a mock-up of GRF of working scenario had been recreated. Here, one ROS2 node receives and interprets the motion, translating it from vision space into robot commands. Safety mechanisms validate the motion, ensuring it fits within safe operational boundaries. The robot then executes the task, turning a single human demonstration into real-world action. The VILMA toolkit could be accessed by a Docker image on your desktop or accessed via the iGenius platform powered by MYWAI technology. In case the user chooses the iGenius platform powered by MYWAI technology, it allows users to upload demonstration videos organized by production site, location, and working area, where each task is stored with its video frames, depth data, and camera parameters. The VILMA toolkit itself is available through the iGenius marketplace within the MYWAI platform, or users can access it from their own file system. Once launched, the toolkit starts by uploading a video recording of a pick-and-place task captured with a Z camera. The VILMA pipeline processes the single demonstration through a series of analytical stages. At first, MediaPipe detects the operator's hand in each frame, extracting the 3D position of the hand center and fingertips using Z-depth data. A Kalman filter smooths the trajectory to remove noise while preserving motion. In parallel, the iGenius toolkit detects the manipulated object and extracts its 3D trajectory, which is also smoothed for consistency. The GMM, which is Gaussian mixture model, segments the trajectory into three phases: rest before pickup, motion during transport, and rest after placement. The release frame is identified in the final low-velocity cluster. From this, two skill trajectories are extracted: reach approach to grasp and move transport to release. Each skill segment is encoded as a dynamic movement primitive DMP, capturing the motion dynamics and enabling adaptation to new start and goal positions without retraining. The system selects the optimal balance between accuracy and smoothness. The final output is a robot-ready trajectory: reach, grasp, move, release. This means a skill learned from one demonstration can be reused across different workspace configurations. The system tests multiple regularization values and selects the best balance between accuracy and smoothness. The final output is a complete robot-ready trajectory: reach, grasp, move, release, assembled into a single executable sequence. The platform's 3D viewer brings together robot, objects, and environment for complete validation. Once validated, the skill is approved and deployed via edge infrastructure. The robot retrieved the skills locally from the node, ensuring low latency. iGenius is built around a human-centric approach, keeping the operator involved at every stage, from demonstration to validation and deployment, without requiring programming skills. Its one-shot learning minimizes effort. iGenius Vilma Toolkit is designed as a set of reusable, modular components. The hand detection module, Vilma Toolkit, is used for object detection. DMP trajectory encoder, and URDF simulation viewer can each be used independently or combined. Aside from the Vilma Toolkit, the iGenius project will also develop a second toolkit, named Fiona Finray Gripper, to support the maintenance of the patented Finray effect. Gripper contributed to the project by partners CRF and the University of GENOA. The iGenius Gripper is a patented modular design featuring elastomeric gripping fingers driven by pantograph linkages. The fingers intentionally deformed to conform around objects of different shapes. Fiona, our condition monitoring agent, uses a PI camera embedded in the finger to capture these deformation patterns at 30 frames per second. The operator stays in control at every stage they demonstrate. Review the trajectory in RViz visualization, validate in 3D simulation, and trigger deployment via the push-to-robot action. The one-shot approach respects the operator's time by requiring just one demonstration. Key challenges include bridging from laboratory to production deployment, optimizing performance for edge hardware, and scaling from single-task learning to multitask sequencing across production sites. Within the one-shot constraint, iGenius has demonstrated successful imitation learning for pick-and-place tasks using automotive components. The pipeline processes a single demonstration and extracts complete robotic skills including hand tracking, object detection, 3D trajectory with DMP encoding, and grasp, release detection. Skills have been validated in URDF simulation and tested on physical robot hardware at the University of GENOA's laboratory. iGenius Intelligent Gripper, using edge neural AI and imitation learning in user-assistive industrial settings.